Hey guys, welcome back to a new video. And this video will be quite different from the other ones because it is solely devoted to showing how to solve this 4x4 determinant. Because a lot of students, when they encounter such a determinant, they get quite intimidated. And well, in this video, I will show that if you just follow the right steps, that you will be able to solve such determinants quite easily. I do assume that you know how to solve 3x3 determinants and 2x2 determinants. If you're not sure how to solve these, I gladly refer to my previous video on how to solve determinants, where I solve 2x2 and 3x3 determinants step by step, so that you get some practice and see how this goes. Without further ado, let's just get into it. So this is the 4x4 determinant that we will try to solve. And in order to solve this, you just have to follow the same steps as before, only now it gets more extended. The calculations become more extended, but the same basic principles apply. So let's get into it. First, you take this 2 and you write it 2 times and you multiply it with the 3x3 determinant when you ignore the row and the column of which this 2 is a part of. In this case, what remains is this 3x3 determinant. So we multiply this 2 by the 3x3 determinant, 2, 0, 4, 1, minus 3, 2, and 0, 2, 1. And again, this is simply these these 9 numbers. The next step is to take this minus 1, so the number on the right of the 2 that we use, and we put a minus sign in front of it, which is very important, which is why I draw it in red. And again, we multiply this number by the determinant that remains if we ignore the row and the column of which this minus 1 is a part. And what remains then is these 3 numbers and these 6 numbers. So we multiply this minus 1 with the determinant made of these 9 numbers. And in this case, we get the determinant of 1/2, 0, 4, minus 1, minus 3, 2, minus 3, 2, 1. And then we can get to the next number, which is this 2 over here. And here again, we get a plus 2 times the determinant that remains if we ignore the column and the row of which this 2 is a part of. Now we get that these 6 numbers and these 3 numbers will make up our determinant that we have to multiply by this 2. This means that we get the determinant of 1/2, 2, 4, minus 1, 1, 2, minus 3, 0, 1. And we can now get to the last number, which we again put a minus sign in front, which is very important. And it's this 3. So we get 3 times. And again, we multiply this 3 with the determinant that we get from the numbers when we ignore the row and column of which this 3 is a part of. And in this case, we get these 9 numbers, which becomes 1/2, 2, 0, minus 1, 1, minus 3, minus 3, 0, 2. And now the unique part of solving a 4x4 determinant is already over. Because at this point, we reduced this 4x4 determinant to 4 3x3 determinants. And we know how to solve 3x3 determinants. So basically the most difficult and, well, daunting part is already over. So let me scroll down, because at this point we have to calculate each of these 4 determinants separately. And again, of course, not forget to multiply it with these numbers in front of it. Let's just do this step by step and start with the first one. So we have 2 multiplied by the determinant of this 3x3 matrix. And again, the determinant of this 3x3 matrix can be calculated in a similar fashion as before. So we get this 2 times, and we calculate the determinant that remains if we ignore the column and the row of which this 2 is a part of. And what remains are these 4 numbers. So we get that this becomes the 2 times the determinant of -3, 2, 2, 1. And there we have it already. Then we have this 0, which gets a minus sign in front of it. So -0 times the determinant that remains if we ignore this row and this column, and we remain with the numbers on the sides of it. So we get the determinant of 1, 2, 0, 1. Then we get this 4, so we add 4 times, again, the determinant, when we ignore the column and the row of which this 4 is a part of, and we get these 4 numbers. So we get 4 times the determinant of 1, -3, 0, 2. And we already have our first term. The same can be done for the second term, which is this term. And here we have to remember that we have this -1 becomes +1. So we have +1 times, and then of course the determinant of this 3 times 3 matrix, which we can calculate in the same fashion. We take this 1/2 and we multiply it with the determinant that remains if we ignore the column and the row of which this 1/2 is a part of. And what remains are these 4 numbers. So we get 1/2 times the determinant of -3, 2, 2, and 1. Again, we get this 0, we put a minus sign in front of it, and we multiply it by the determinant. By now you will know how it goes. Remove the row and column of which this 0 is a part of, and we get these 4 numbers which will make up our determinant. So we get 0 times the determinant of -1, 2, -3, and 1. Then we add this last number, again a 4, so 4 times the determinant when we remove this and this column and row, and we are left with these 4 numbers to take the determinant of. So it's -1, -3, -3, 2. And again, now we have already the second term. The third term will be a +2 multiplied by this 3 times 3 determinant, and by now we know the drill. We take this first number, 1/2, and we multiply it with the determinant that remains if we cancel or ignore this column and this row of which this 1/2 is a part of, which are simply these 4 numbers. So we get 1/2 times 1, 2, 0, 1. Then we take the next number, which is 2. So we get -2. This minus sign is very important not to forget. The determinant of these 4 numbers. So we get the determinant of -1, 2, -3, 1. Plus this last number, 4 times the determinant when we ignore this column and this row. So we get the determinant of -1, 1, -3, 0. And we have our third term. Now to get to the last term, we have this -3, which is important to remember that we have to take with us the minus sign. So we have -3 times the determinant of this 3 times 3 matrix, which is 1/2 times the determinant that remains if we remove this column and this row, which is these 4 numbers. So we get the determinant of 1, -3, 0, 2. This next number, a 2, with a minus sign in front of it, times the determinant of these 4 numbers. So this becomes -1, -3, -3, and 2. And then the last number is this 0. And again, we ignore this row and this column, and we multiply it with the determinant formed by these 4 numbers. So we get plus 0 times the determinant of -1, 1, -3, and 0. And at this point, we are now finished with calculating 3 times 3 determinants. So what we did is we reduced these 4 3 times 3 determinants to effectively 12 2 times 2 determinants. And again, these 4 3 times 3 determinants came from 1 4 times 4 determinant right here. So in a sense, we're reducing the problem into more problems, but these problems are problems that we can solve. And this way we solve the thing that we couldn't solve in the beginning. And now we are left with 2 times 2 determinants, which we know how to solve, of course. So we have 2 times this first term, which becomes 2 times then the determinant of this 2 times 2 matrix becomes the multiplication of these 2 numbers minus the product of these 2 numbers. So we get -3 times 1 is -3, minus 2 times 2 is 4. And we already have this first term down. Now this second term is 0 times this determinant. And 0 times any determinant is just 0. So we don't have to calculate anything here, we just add 0. Then for this last term, we have 4 times this 2 times 2 determinant. So plus 4 times, again, the product of these 2 numbers minus the product of these 2 numbers, which becomes the product of these first 2 numbers on the diagonal becomes 2 minus 0 times -3 is 0, so it just becomes 0. And we already have our first term. Let's go to the next term. So we have this plus 1 in front of it. So we have plus 1 times. Then we get, of course, our 3 determinants that we have to calculate. We don't forget this 1/2 in front of it. So we have 1/2 times -3 times 1 is -3. And then we multiply this with -2 times 2 is -4. And we already have our first term. Then again, we see that we have -0 times a determinant, which is again very conveniently 0, plus 4 times this number times this number is -2. So 4 times -2 minus, and now this gets a bit tricky. So -3 times -3 is +9, but we have to minus this number, so we have -9. And we already have our second term. Let's go to the next one. So we have this 2 in front of it, so plus 2 times, then the sum of these 2 times 2 determinants. The first one, we don't forget this 1/2, so 1/2 times the determinant of this one, which is 1 times 1, which is 1, minus 0 times 2, which is 0, so -0. Then we'll get this term, so -2 times -1 times 1 is -1, minus -3 times 2 is -6, so we have to minus -6, and I will just write it out fully here, not to get any confusion, and calculate it in the next step. Then the last term is this plus 4, so plus 4 times the determinant is -1 times 0 is 0, so we have 0, minus -3 times 1 is -3, so -3. And we have our third term, and we go to the last one, which is -3 times the sum of these 2 times 2 determinants. So we have minus 3 times, again, don't forget this 1/2 in front of it, 1/2 times, the determinant will be 1 times 2, which is 2, minus 0 times minus 3 is 0, so minus 0. Then we have minus 2 times, the determinant of this is minus 1 times 2 is minus 1, minus the product of these two numbers, which is minus 3 times minus 3 is plus 9. So we have minus plus 9 is minus 9. And then for our last term, we are in luck because we just have plus 0 times this determinant, which is just 0. So we are finished here. At this point, we don't have any determinants left, only some algebraic equations. So we have reduced the 4 times 4 determinant to 4 3 times 3 determinants, which we reduced to 12 2 times 2 determinants, which we now have solved. And well, we are left with this simple sum, which we are going to calculate right now. So we have 2 times minus 7 is minus 14, plus 0 is 0, plus 4 times 2, which is 8, so plus 8, plus 1 times, and then we're arrived at this term, 1/2 times minus 3 minus 4 is minus 7, so we get minus 7 over 2, plus 0, which we can just drop. And then here we have 4 times minus 2 minus 9 is minus 11. So 4 times minus 11 is minus 44. Then we get to this term. So plus 2 times 1/2 times 1 is 1/2. Minus 2 times, and now this becomes this tricky part. So we have minus 1 minus minus 6. So it's plus 6. So minus 1 plus 6 is plus 5. And then we have to multiply it with this minus 2. So we get minus 2 times plus 5 is minus 10. And then we get 4. So plus 4 times minus minus 3 is plus 3. 4 times plus 3 is 12. So we can just put a 12 here. And then the last term, we have minus 3. So this becomes minus. I was too fast here. So minus 3 times 1/2 times 2 is simply 1. Minus 2 times minus 2 minus 9 is minus 11. And minus 2 times minus 11 is plus 22. And this term just, well, we add 0 and it remains 0. Now we're almost there. We just have to calculate these few brackets here. So we get 2 times minus 14 plus 8 is minus 6. So we get 2 times minus 6 plus 1 times, so this 1 can drop. We have minus 7 over 2 minus 44, which is minus 47.5, because 7 over 2 is minus 3.5. Then plus 2 times 1/2 minus 10 plus 12. Minus 10 plus 12 is 2. 2 plus 1/2 is 2.5. And then this last term, minus 3 times 23. And now we're really almost there. So we get minus 12 minus 47.5 plus 5 minus 69 for a grand total of minus 123.5. And this is our final result. And I checked it, we didn't make any mistakes. So this number is the result of this 4 times 4 matrix. So this is how you calculate a 4 times 4 determinant. I know this video was a bit different than other videos because we only did one exercise, but I thought it would be good to go step by step through such a 4x4 determinant. I hope you learned something. If you liked the video, give it a like. If you want to see further content, then you just subscribe, and I will see you guys in the next time. Bye.